We're going to show you how to work with families of functions in the graphing sticky using sliders, which is a great way for students to discover the different types of functions and also what those coefficients and constants actually do to the family, the parent function. So I'm going to open a graphing sticky, and let's just start with linear. And so a parent function of a linear is simply y equals x. And obviously you'd have students, explore what's a key point on this, 0, 0, what makes it a parent function, it's going through the origin, things like that. And then what we might do, you could actually do something as simple as this. Let's change this parent function and put a value in front of the x. So you could use an actual number. So we could do 2x. And what does that do to the parent function? How did we change it? Well, we're multiplying this x by 2. What did that do? So when I hit execute, I see that it kept it at 0, 0, like that's still where the y-intercept and x-intercept are, but the 2 forced the slope to change a little bit, right? Or the tilt of the line if we haven't discovered slope yet. So you could do that. Very easy to do that. But what I want to show you is that for discovery, you kind of want students to have a general idea. So maybe we're looking at slope-intercept form right now. So instead of a 2, I'm going to go back up to this equation, and I'm going to put the variable that we tend to use for slope, which is m. So I'm going to use that, and I'm going to put a multiplication here so that Classpad has multivariable recognition. So if I don't put that multiplication there, it thinks that mx is just a variable. So I want it to look at m as the variable and m as the coefficient, and x as the variable in the equation. So now watch what happens. Now I have a slider, and a slider that corresponds to that variable that I'm using. So all I had to do is put in the letter. I'm going to change my step right here to step by ones. And now I can move the slider and students can explore. Because of this, they can look at that parent function, y equals x, and how does placing a coefficient in front of that x, it's multiplied by x, how does that impact the parent function? So the parent function is going to basically stay locked. And as we move this slider that controls this m value, right now it's 1. So right now they are on top of each other because y equals x is really y equals 1x. But what happens if I say change it to 3? What happens to my line? So that value of m made my line tilt different. So then we could talk about that. So what happens if I make it 0? And now, it doesn't have any tilt, right? So that is just a line with no tilt, no slope, that type of thing. Well, now let's make a conjecture. What if I make it be negative? Well, positive made it tilt more up. So let's assume negative is going to make it tilt, change the direction maybe. Let's see. And it does. So they can start exploring just using the sliders and get a sense of what these coefficients do. And now, one of the nice things about Classpad is you can hide lines. I want to hide this particular one. So I'm selecting the color and I'm going to hide the graph. It's still there, but now let's look at what if I add in, there's my parent function, but this time I'm going to add a constant instead of a coefficient in front of x. So I'm going to add in my b. What happened to the line now? Well, it has the same exact tilt or slope, but let's actually look at some key points here. Now my point on this y-axis is up here at 1, and I also have a point down here on the x-axis. What do those indicate? Well, by changing this constant, I've moved my line. It looks like I moved it up. And what is the value of b? It's 1. So it looks like it might be matching this point on the y, but maybe I'm not sure. So let's try to move it, and let's change the step again. So all you have to do to change step is click on that and put in a number. I like to start with students stepping by 1. And let's see, after we make some conjectures, well, if I want that line to go higher, maybe I want it to go up here, that seems like I might have to go positive. Let's check it out. And now my value of b is 5, and let's look on that line now. this point is 5. So it seems that the point that's on the y-axis corresponds to this b, so that might be where it's intersecting the y-axis. So if I want it to come down here, I might have to go into the negatives. Let's test it out. So the sliders allow students to see things immediately, test things out, and really kind of come to the understanding of what these values mean. So that's just using slope-intercept form. You could also do the standard form of a line and talk about A, B, and C, but what I'm going to do is show you that this is a process you can use for any type of function. So we're using a linear function here, the parent function, and then looking at slope-intercept. I could look at standard form. I could look at point slope form and really explore what those coefficients H and K do, that type, X and Y, Y1. But let's go down and explore a different type of function. So let's get a second graph. And this time let's change the color here. Let's make this one darker. And let's do a quadratic. So the parent form of a quadratic is y equals x squared. And there's my parent function. And now let's kind of do the same thing. So I'm going to step right into it. And let's do the standard form of a quadratic. So that's a. And remember, you want to make sure you do the times here so that it doesn't think the ax are the same, are just one variable together. So a times ax times x squared plus b, times x plus c, and let's make that capital, equals your y. So this is just the standard form of a quadratic. So notice it plots another quadratic and it automatically defaults all the sliders to have the value of 1. So the first thing you might do is say, okay, so this doesn't match our parent function. So which value, let's compare them. What's different? Well, a, which is in front of x squared, and this is x squared, is a value of 1. So this piece right here is the same, but the parent function doesn't have any of this b, x, and c, and notice that these values, b is 1, c is 1, so if the parent function doesn't have any of these, that means these might need to be 0 if I don't want to see them. So let's, and again, I like to change the step when I'm first working with students to a 1, and we could now move these to 0 and see if we can match up to the parent. Okay, so that matched up to the parent. So now you could explore each one of these individually to help students get an understanding of what each coefficient and constant is doing. And that way, when they see a quadratic, they probably already have a sense of what it's going to look like. So for example, what happens if I make a larger positive number? Well, it seems to make the function get smaller, skinnier, right? What happens if I go negative? Is that going to make it larger? Let's see. Oh, it flips it. So a negative flips my function. So they can really start exploring. And then here's where you can also bring in a different form of the equation. You could bring in the vertex form and use, if some of them have the same coefficients, use the same coefficients. So you could say y equals a, oops, we gotta make sure we do times, x minus h plus k. Oops, I forgot squared. Do have to remember it's quadratic. So now A's the same, right? So A is obviously turning, determines whether it's up or down or how skinny it is, but then what does H and K do? So notice we've added some more sliders. So again, any function you can first put the parent function in and then use sliders to represent those coefficients. So you could do a cubic, a quartic, and whatever function you want, you can do the same thing simply by using variables instead of numbers, which for each one creates a slider. And then students can explore and kind of come to understand what each form of the equation has done because they are seeing it in relation to the parent function.